All right, so we've got on the first one here, you got a Ferris wheel, 60 feet in diameter, rotates once every minute. So right here, this is going to tell you what the period is. So we know our period is 1 minute or 60 seconds. All right, the center axle is 40 feet above the ground, right? So the height from the ground to the axle is 40 feet. And then the diameter of the wheel is 60 feet. So I can put 60 feet there. All right. And now what I have to figure out is what's the max height and what's the minimum height based on that drawing. Okay. Corbin, what would be the minimum? Okay. And how did you get that? So that's 30 and 30. So that's 30 plus that has to be 40. So the distance above the ground would be 10. These two together are going to make 40. So our minimum is going to be 10, right? And Cade, what's our maximum going to be? 70. Okay, so we're going to take 40 and 30. So our max height is going to be. Say that again? The minimum would be 40. So, well, hey, right here, that's the mid. So the mid and the height of the axle are the same thing. Because your curve is going to go 30 above it and 30 below it. So our mid is 40. So the mid and the axle are going to be the same. That's always going to be the midpoint. And then all you do to get the max and the min, okay, is you take this one up here, this is the midline plus the radius. That's the midline plus the radius. And then the min is the midline minus the radius. So that's how you get all your numbers that you need. So I know that this graph is going to go 30 above this line and 30 below it. It's not going to go above 70. And it won't go below 10. line is the height of the axle. All right, it says sketch a graph to show the wheel's motion of how the height of the passenger will vary over time. The ride starts with passenger loads the seat at the bottom and does not stop. So we know that at 0 seconds, I'm going to be 10 feet above the ground. And then to get these numbers, I just took 60 seconds and divided it by 4. And that's what you're going to count by, 15 seconds. So each one of these just increases by 15 seconds. All right, so at 15 seconds in, I'm going to be at this started at the minimum. Okay, then let's say I'm rotating clockwise. We're going this way. Then 15 seconds from then, here I am at 0 seconds. Then at 15 seconds, I'm going to be at 40 feet. So that's going to be 40. So I'm going to estimate where 15 is. Then at 30 seconds, I'll be all the way at the top, which is 70. And at 45 seconds, back down to the midline at 45. So I get that. And then I'm back down to 10 at 60 seconds. 70, 40. So we went min. Then we went mid. Max. Mid. And min. And then it just repeats again. That cycle is just going to repeat. So I'm at 10, then I'm going to go to 40, 70, 40, 10. I'm back to 10, 75, 75, yikes. Here we go. Yeah. They're not very hardy. Okay. All right, so now that's the graph part. Any questions on what I did there? Okay, now the next thing you're going to do is you're going to write out the equation. All right, and then there's two ways we can write this equation. With the b multiplied through, or with the b outside the parentheses. These are going to be the same thing, they're just written different. All right, so most of the things are pretty easy to solve for. The phase shift is a little tricky, but other than that, amplitude is just your highest, take away your lowest, divided by 2. That gives me my A value. So your amplitude is always going to be the same as your radius. And your vertical shift is going to be your axle. So if we skip down to the last one, I'm going to take my highest, but add my lowest. Vertical shift. So this is always going to be the axle height. So right from the get-go, you'll always know the radius, you'll know A, and you'll know D just from the problem. That's D. Then if this is the diameter, then you cut the diameter in half. If it said it was 60 feet radius, then you'd use 60. But this is going to be 60 divided by 2, which is 30, and that's going to end up being my amplitude. Okay, so we have A, that's 30, sine. We got D, that was 40. And the Y1s, that's just how you type it into Desmos, but so if you don't have the Y1 on there and the X1. All right, now we got to get the frequency, B, and then the phase shift, right and left, which is C. Okay, so to get the frequency, you're going to take the horizontal distance between the two maximum points as your period. Now, you already know your period. So you don't have to do this part. If you did, there's a max 30, there's a max 90. And if I did 90 minus 30, that's going to be my period, which I already know is 60 seconds. But if it was a problem where we didn't know the period and we had to figure it out from the graph, That's how I could do it from the graph. All right. So what you do is you're going to take this formula, period, and you're going to take out the word period, and you're going to put in 60 seconds. And you solve this for the variable b. So multiply both sides by b. And divide by 60. What's pi? Say that again? We know that the period is 60. So b's not 60. Okay. Right here? Yeah. So I have to get b out of the denominator. So I multiply both sides by it. And then I divide by 60. I guess I'm not quite sure what you're asking. Are you sure? All right. Now I'm going to reduce that to lowest terms, and that would be pi over 30. So that's the frequency. That's the exact value of the frequency. When you do it on Desmos, it's going to give you the decimal version of that number. Now I can put that here. Here. And now all I need is the phase shift. Okay, so what you do to get this phase shift is a normal sine curve. Okay, so we divided the period into 4 parts. That's this right here. Okay, this is a normal sine curve. So on a normal sine curve, the first max occurs. If I divide this into 4 parts, the first part is where the first max is. So the max for a regular sine, it's always going to occur at the second mark here. Okay, this is 0, this would be 15, this would be 30, 45, 60. That's a normal sine curve. Okay, but if you look at ours, look at where the first max is on ours. Okay, so our first max occurred at 30 seconds. So for our data, our max occurred right here. So you have to figure out what are you going to do to the sine curve so that this max occurs in this under the 30 instead of under the 15. What would you have to add to this to move it to there? 15 to the right. 15 seconds right. Well, no, you just got to add 15 seconds. So the way we would add, this tells us that the phase shift is 15 seconds to the right. And then the maxes would line up. So I'm trying to figure out, how do I take the regular sine curve and move it so its mins and maxes match up with the data. So in order to get this max to line up with this max, I got to move it over one box, which is 15 seconds in this case. So our C value is 15. All right, now here's where you got to be careful. It's not 15 in this one. Okay? Because if you multiply these two out, that's how you get this value right here. So this is really pi over 30 times 15. So this guy's going to equal pi over 30x minus pi over 2 plus 40. Okay. Pi over 2 came from this times 15. Pi. So it's really important to understand that when it's written like this, the phase shift is disguised. Okay? This is not the true phase shift. Yeah, that's fine. Okay, so when it's written in this form, okay, in this form, the phase shift I have to take C and divide it by B. Like we did, when we first started doing these, that's what we did. So the reason why people like the other one is that this is the true phase shift. It's not disguised. So the form on the left gives you the true phase shift. The form on the right, you got to take C and divide it by B to get the phase shift. And that's a big difference between those two formats. So students will always make the mistake that, oh, pi over 2 is the phase shift. It's not the phase shift in this case. If it was written like this, it's the phase shift. Okay. Now, that's doing it by hand. Okay. Then we learned, or actually the first thing we learned was how to do this using Desmos. All right. So you open up a Desmos graph. And if you create an account, you can just use the same Ferris wheel problem that we've been doing the last few times. Desmos. Okay, and we're going to take the information from our table and put it into a Desmos table. So I click Add Table. And let's see, this was 10, then it went 40, 70, 40, 70, 10, 30, 35. And see, Desmos recognizes a pattern. So you see it automatically is adding 15 seconds every time. Okay. Zoom out, we should see our dots. There. Anybody need help there? Okay, now we're going to ask it to make the curve. So you go Y1. Okay, then by the number 1 key is the tilde key or the squiggle. Now I'm going to type in the first form, which was A sine. Just type in the word sine, and then it was B parentheses X1 minus C. And then to close it, it tells me I got to put 2 parentheses, and then plus D. And you can see it fits the equation perfectly. And that's what this tells me right here, this R1. The R squared being 1, that means perfect fit. Now, if I want it in the other form, then I just type that in. 1 squiggle A sine parenthesis B X1 minus C plus D. And there it is with the phase shift is hidden in that. Okay, and then I just take those, copy those onto my graph here. Values. 15. 1. Down here, 30. 5. 7. And then we got the 2 equations. Yeah. And the only difference here is that they're written as decimals. So this would be 30. Now B in this case, and what you would normally do is you'd go out 3 decimal places. And then this one. All right. Then we're going to answer a couple of questions using Desmos to answer it for us once we've got these typed in. All right. So it says, use your Desmos graph to approximate the height of the passenger who's been on the Ferris wheel for 85 seconds. So what you're going to do is you're going to draw a line x equals 85 on Desmos. So that's going to be a vertical line. And where it touches the graph, that's going to be the height. Okay, so we'll pull this guy over. And I just go down here and I go x equals 85. And then I go to that intersection. And that's my answer. So at 85 seconds, I'm 65.98 feet above the ground. Well, we always go to 3 significant figures, so I'll show you. So that's going to be 66 when I round it. Okay, so okay, so 3 significant figures would be 6, 5, 9, 8. And I'm going to round it. This is 1, 2, 3. So the 8 makes that 9 a 10, which would make that 5 a 6. So I would say approximately 66 feet. Now on the second question, instead of drawing a vertical line, you're drawing a horizontal line. So because it's asking you approximate the number of times during the rotation when the passenger is 50 feet above the ground. So I'm going to draw a line y equals 50. That's going to draw a horizontal line. This is going to be a horizontal line. All right, so we go down. Desmos. And get rid of the 85 and make this y. And each one of these, where it touches the graph, my data went up to 120, so I'm just going to go out to 120. Pardon me? What did the question say? One rotation? Let's see. Can't remember. Okay, so I think that would be one rotation. Yeah, so you wouldn't write any answers that were past 60 seconds. During the rotation, yeah, so we'll just say one rotation here. So anything above 60 seconds, we won't count. So the number of times that we're at 50 feet is 2. Because the next time we're at 50 feet, we're on the second turn. Okay, so one rotation is to here. That's 60 seconds. So at 18 and at 41. So our answer here is going to be the number of times is 2 times. And they occur at 18.2 seconds and 41.8. Right? Okay, so when you come in tomorrow, guys, you're going to do the second part and on your own from start to finish, and that will count as a classwork assignment. Alt.